On page 3 in the notes. Today we're going to be solving radical equations, and radical equations aren't too bad to solve when you think about how we have solved exponential equations in the past. So let's say I have x squared equals 4. How do I solve this for x, or how do I get rid of the squared? Square root, square root. And when I square root, what do we need to include in front of that? Plus or minus 2. And this is because if I square positive 2, we get 4. And if I square negative 2, we also get 4. So now the flip side. What if I have, let's see. What if I have 9 equals the square root of x? I want to isolate my variable. How do I get rid of a square root? What's the opposite operation? We square both sides. Woo! So I square both sides. And 9 squared is 81. And the squared cancels out the square root. And I get x. Now here's a question. Do I want to put a plus or minus in front of this one? The square root of positive 81 would be 9, but what's the square root of negative 81? 9i, which we do not want. So when I square both sides, we don't have to include a plus or minus. If you're like, well, that's pretty cool. I already like solving this. We're way better than square root. But we do have a slight problem. What if I have the square root of x equals negative 9? If I think about this conceptually and plug in 81, what's the square root of positive 81? 9. What's the square root of negative 81? 9i. Is there any way for me to get a negative from a square root? That is a no, and we call this a red flag. When you have the square root of something equal to a negative, that is a big red flag, and we can actually go straight to our answer of saying this is no solution. Now the problem is, with a problem like this, when we try to solve this algebraically, the problem with the problem is the problem. If I want to get rid of the square root and square both sides, what happens when I square negative 9? What's negative 9 times negative 9? A positive 81. So we get this algebraically, and it's like, oh, psych, I guess it works. Just kidding. When we plug it back in, it doesn't. What do we call an answer that we can solve for algebraically, but that it straight up doesn't work when we plug it back in? Starts with an E from last unit. Extraneous solution. So 81 here would be an extraneous solution because it doesn't actually work when you plug it back in. Now, what's nice about this is you can identify these based on the red flag of saying a square root is going to output a negative, but if you don't catch it at the red flag, you can plug back in to check it and say, hey, the square root of 81 is not negative 9, so this must have no solution. So our final answer for a problem like this would be no solution. So that's basically what we're going to be doing here, is to get rid of a square root, we square both sides. To get rid of a cube root, we cube both sides. To handle these fractional powers, they're a little bit grosser, and we're going to wait for those until tomorrow. So let's go ahead and just take a look at problem B. We'll start with problem B first. Now, do I want to square right away? Why not? What's your gut telling you we should probably try to do first? Move the 5. Excellent. We call that process of moving the 5 isolating the radical. So that's going to be your first step in this problem, is isolating the radical first. So just like if I had x squared plus 4 equals 4, we'd want to move that 4 over before we square root. So you always want to isolate your variable stuff first. So this is one chunk. So we're going to go ahead and subtract 5 to isolate the radical. So square root of x minus 8 equals 2. Can I steal that negative 8 out of the radical? Nope. That stuff is trapped underneath. So my radical is isolated. So how do we get rid of it? Square, square, both sides. So we power up by 2 over here. Power up by 2 over there. I strongly recommend writing those parentheses in because this is going to help us as we get into some more complicated problems that require FOILing and some of that red flag stuff that we talked about above. So if I square 2, 2 times 2 is 4. What happens when I square this radical? The squared cancels out the square root, and I'm just left with the stuff that was underneath the radical. So powering up by 2, or squaring both sides, breaks it free. What would be our final step in solving for x? Adding 8. So x is 12. Before I put a box around it, though, we are going to check this by plugging it back in for x in the original problem. What's 12 minus 8? 4. What's the square root of 4? 2. What's 2 plus 5? 7. Boom! It works. So that really is our answer. Easy peasy? Yeah. Más o menos? Let's go ahead and take a look at C then. So we see a square root and we see our variable trapped under the square root. First, we isolate the radical by adding 1 to both sides. So plus 1, plus 1. So the square root of 3x plus 4 is equal to 8. How am I going to get rid of that square root? We're going to square both sides. So the squaring cancels out the square root, and I get 3x plus 4 equals 16 question mark. Sometimes our Monday brain goes 16, but what should it be? 64. So make sure you are squaring both sides. And if you're like, my dumb brain would never do that, sometimes it will just because we're not used to squaring as an operation when we're solving. We're a lot more used to doing things like multiplying both sides by 2, dividing both sides by 2. So it's bound to happen sometimes. So just when you're checking your work, make sure that you are squaring those constants on the right or the left side. So this gives me 64. So then what do we do now to solve for x? Subtract the 4. So 3x equals 60. Divide by 3. And x equals 20. So we plug 20 back in. 3 times 20 is 60. 60 plus 4 is 64. Square root of 64 is 8. And 8 minus 1 equals 7. So we can always plug to check, or you can be on the lookout for the red flags. The red flags happen when I've got the square root isolated and if it is equal to a positive number or a negative number. So this is all good. We got a green flag for go. This is all good as well because I'm getting a positive 2 versus a negative 8. Questions so far? Let's go ahead and take a look at problem A now. So what's different about this one? The index, we've got a cube root. We're still going to start by isolating the radical. So let's go ahead and add 4, making sure we include that little index of 3. So plus 4 gives me a 1 on this side. So how do you think we're going to get rid of a cube root? We're going to cube both sides. So the cube takes care of the cube root, and x is broken free. And what's 1 cubed? 1 times 1 times 1 is 1. We plug back in. Now, I'm pretty sure we have this added on our sheet. It might not be on the purple sheet if you have that version of it. So if you don't have it written there in the first row, I want you to add that 1 is a perfect everything. A perfect square, a perfect cube, a fourth, a fifth, and a sixth. It's not one we normally worry about just because we wouldn't use it when we're simplifying radicals. We're not going to take out 1 and it's not going to do anything for us. But with solving, knowing that 1 is a perfect cube is important here. Because when I plug 1 in, the cube root of 1 is 1, and 1 minus 4 is negative 3. So our answer checks out. I want you to put a star by problem D. Our first issue with this one is kind of subtle. We've got x in 2 places. Can I subtract this x and help it be friends with that one? No, that one's trapped inside the radical. This one is not. So our goal, our initial goal with this is still the same of trying to isolate the radical. Well, that radical is already by itself on the right side. So how are we going to break that variable out of that square root? We are going to square this side, but then we are going to square the left side. Notice that I'm putting it in parentheses. How do I square a binomial? FOIL! So x minus 2 squared is x minus 2 times x minus 2. And that equals x. So foiling this, x times x, x squared. X times negative 2, negative 2x. Negative 2 times x, negative 2x. Negative 2 times negative 2 is a positive 4. And at this point, you're probably looking at this going, looks pretty awful now, Mrs. Cairo. How awful does it look? What type of equation are we now looking at? It's not a radical equation anymore. What is it? What's that little power of 2 tell us? We've got ourselves a quadratic, folks. And what do I do to solve a quadratic? First, it needs to be equal to 0. Do we want to move everybody over to the left or everybody over to the right? Everybody over to the left, because moving that little x is not a big deal. So x squared, negative 2x, and another negative x, that's negative 5x, plus 4 equals 0. So if you have a quadratic, it's got to be equal to 0. And then what do I do after that? On our last test, I had some people who tried to square root this. Can I square root when I've got x squared and x? Nope. We can square root if there's only x squared, but when I have both, we have to either use the quadratic formula or factoring. Which do you want to use? Factoring. We will continue with this problem after lunch.